Oh my god, why is my fucking screen not updating? So again, I was just practicing, studying for my test, and I came across this problem from MIT, and I found it very interesting, so I want to share it. Okay, so first, for part A, we need just to show that this field is conservative, right? So F is equal to del F, and we say that F is equal to Q, not Q. I usually write it as P, Q, and then that del F has to be equal to F all taken to the derivative of x, and F taken to the derivative of y. So that's the two facts. We just need to show that using this. So if we just take this derivative with respect to x, we would see that we get 3 squared y, and then we get this right here is 0 because y with respect to x is 0. It's like a constant. Okay, now we gotta do this whole thing with respect to y. Well, it comes x cubed plus 3y squared. Okay, so not too bad yet. So that's just useful to know. We just want to see that. The question asked us that. But here's the fun part. This is where we're going to evaluate it 3 different ways. But let's see how that turns out. So number 1, we just want to do it directly using this path in these coordinates. Okay, so first I'm going to draw a picture. Okay, so y squared equals x. That is the same thing as y equals square root x. But I'm actually just going to write x as my vertical axis, and we'll write y as my horizontal axis. This way, because I always know what a parabola looks like. I actually sometimes forget what the square root graph looks like, but I know this for a fact. Yep. Okay, I just made the graph look a little bit nicer because my thing looked ugly at first. Okay, and these points, right? So this is written as x and y, but I'm writing my graph as a y versus x. No, I didn't say that correct. What I did is I switched the axes here, right? So then I have to switch these points. So it's going to be -1, 1. And guys, like, the only reason why I did this is just because I think it's easier than actually drawing the square root graph. And it's like, because everything's given like this. I mean, x is a function of y looks a lot nicer than y is a function of x. 2, 1, 1. So, I mean, really nothing that big is a deal. I mean, nothing that big is changing here. We're just making our life simpler. Okay. And let's state the direction. So it goes from here to here. And this is -1. This is 1. And they both go like that. So this is our first path we're going to take, and this is doing it directly. Right. So if we see here, I mean, we're quite literally given x equals y squared. Okay, and we take this derivative, we get dx is equal to 2y dy. Oh my god, why is my fucking screen not updating? Okay. Yeah, so dx is equal to 2y dy. Okay, so we have these two facts, but before we decide what our main variable is, let's just write out what we think our line integral is going to be. So remember we write it as p dx and q dy, where p is this, q is this. So 3x squared y dx plus all that 3y squared dy. Okay, so now we want to convert this fully into one variable, and we just got to pick that variable. I usually like to pick it by looking at the graph. Okay. I think we should let it be y, be our main variable, because that way we could have our bounds be -1 to 1, which is really easy to describe if y is our main variable. So let's do that. Let's just write y is our main variable. Okay, so we'll go from, that's really ugly integral sign. We'll go from 1 to -. Okay, now look at that, we got a beautiful integral sign. So y is our main variable. We want this to be purely of y. Okay, 3x squared that's the same thing as 3y squared and y. Then dx becomes this, just 2y dy. Okay, and then all of that, well, oh, x cubed. Well, that's x, so this will become y squared cubed plus 3y squared dy. Of course, we are going to simplify this. Okay, y squared squared, y to the power 4, and we have a y here, so that's y to the power 6 times 6, 3 and 2. So 6y, 6 dy. Oh, that's y to the power 6, and that's y squared. y6 plus 3y squared dy. Okay, and then we're going to do it again. We're just going to simplify everything. But before we do that, we have a 1 here, and we have a negative 1 here. And we have all even powers in our integrand. Okay, so I'm going to write this as 1 to 0 times 2. And we see a 6y squared, and we see a 6y squared, we see a 6y to the power 6 and a y to the power 6. We're going to add them. 7y to the power 6. And we have a 3y squared here. dy. So this all will become what? So 7y to the 6. That's just going to become y to... Why am I writing integral sign? It'll be y to the power 7 plus 3y to the power 3 divided by 3. The 3 can go away. And this is all going to be, I need to make space. Okay, that's going from 1 to 0, so we get 2. And that's just 1 plus 1, which is 4. Okay, so 4, right? Now, in theory, we should have 4 here for our answer, 4 here for our answer, and 4 here for our answer. Let's see if that happens. Okay, I'm going to start on the next page. Yeah, I lied. We're not going to put another page. We're just going to shrink it and put it over there. Okay, so the next one, we can use an independent path. I mean, we have our path is independent, so we can pick a simpler path. Okay, so why don't we make our graph here? And let's just stick to x and y instead of doing y and x, like how we did for this one. Let's do x comma y, like just literally how it is. It's negative 1, negative 1, to 1, 1, 1, negative 1, 1. And let's indicate that this is going up, right? So it's going up. That's our graph. So then we could think about, okay, well, how can we describe the situation here? Well, x is equal to 1. I mean, that's the line, right? X is equal to 1. That's a vertical line. And then let's describe how y varies. Well, y varies from negative 1 to 1, as it is right here. Okay, so if x is equal to 1, and y is equal to negative 1, 1, how should we pick our main variable? Okay, so if we let x be, if we were to let x be our main variable, then dx would be 0, right? If we were to let y be our main variable, then y is equal to y and dy is equal to dy. So let's let dy be our main variable, and let's just write dx is equal to 0, y is equal to y, thus dy is equal to dy. So just wrote down all the things I just said. Okay, so if we make those, let that be true, I mean, not if we let it be true, it is true. Let me make a bigger integral. I don't know why I'm writing like a little bitch. Okay, and what is y varying from? Well, 1 to negative 1. Okay, and remember, it goes like p dx and q dy, or this is p and this is q. Okay, so if p is this, 1 second, I don't know why yeah, that's an x. Okay, so we would get 3x squared y dx plus x cubed 3y squared dy. But we want to make this all y. So to go from 1 to negative 1. Okay, that 3x squared. Okay. Oh, x is just equal to 1. Okay, we'll just write it. 3y. And oh, dx is just equal to 0. Okay, that's it. That's all we're doing. x cubed, well, that's the same thing as just 1 cubed, which is 1, and 3y squared. Yep, y is equal to y, so it's just 3y squared, and dy. Alright, so I'm going to write it now over here, and I'm also going to do that trick, because we only have 3y squared. We can definitely do this trick here, where we times the integral by 2, and make our bounds 1 to 0 to get rid of that negative 1, just so we don't have to do extra math later on. So 3y squared, dy, and then this becomes 2y plus y cubed. The 3 and the 3 go away. That's divided from 1 to 0, which is equal to the 2, 1 plus 1 cubed, which is 1, which is equal to 4. Okay. Look at that, we get the same answer here, and we get the same answer here. Let's do it again, but now we're going to use the fundamental theorem of line integrals, and we should get the same answer, right? We should get 4. Let's see what happens. Okay, yep, so for part 3, we're going to use the fundamental theorem of line integrals. If you don't remember, that's f dot dr, and since we're saying f is the same thing as del f, big F is equal to del f, then we could write del f dot dr. It's literally the same thing, we're just swapping in something. FB, we're not swapping something, we're swapping in the exact same thing. FB, FA. And what we like about this is just calculus by subtraction, I like to say. Okay. Well, first, what is f of b? Well, f of b is, well, what would be b? Okay, I think this would be b, right? B is our second point. It should be 1, 1. And if it's 1, 1, we got to plug 1, 1 into all of that. And 1 cubed times 1 plus 1 cubed, just 1 plus 1, which is 2. Okay. And then f of a, which is the same thing as f of 1, negative 1. Let's think about this. So it's 1 cubed, 1 times negative 1, and plus negative 1 cubed. Negative 1 cubed is negative 1. So negative 1 minus 1, which is equal to negative 2. Okay, and then as you can see, we just subtract them. So it becomes 2 minus negative 2, which is equal to 4. Oh, look at that. Spoiler alert. It's 4. I mean, I think everybody saw it coming because I kept saying it. And let's see if we can do it one more way. And let's see if we can do it using our common variable t, using a vector function. Okay, so I'm going to write this using r. Why am I writing big R? R is equal to RO plus TV. And let's let RO be this one, which is 1 into 1, and TV. Okay, and V would be the position vector change here, so it should be 1 to 1. Okay, there's no change there. And it goes from negative 1 to 1. Okay, that's a change of 2. And this would be, okay, 1 plus t times 0 is 1. And negative 1 plus 2t is 2t minus 1. Okay, and this would be x comma y. And if we were to find dr, well, dr would be the derivative of this, which would be 0, and the derivative of this, which would be 2 dt. Okay. And let's write f as a function of t now. So f, we said, was equal to this. And f is 3x squared y. So if x is 1, it's 3, 1, 3, 1 squared, and y is 2 minus t, 2t minus 1. Okay. That's the same thing as this, just using t. Okay. X cubed, well, that's just 1 cubed. Okay, and 3y squared, that's 3 and times y squared at this. So we'll write it as 2t minus 1 squared. And let's simplify all of this. Okay, that's 3 times 2t minus 1, which is 6t minus 3. Okay, and then this is 1 plus, we'll take the square of that, which would be let me think, 4t squared minus, okay, 2t times negative 1 is negative 2t. Negative 2t times 2 is 4t. And negative 1 times negative 1 is, as you know, positive 1. Okay, we gotta simplify it a little bit more just before we can use it. Nope. So it's 6t minus 3. And we'll go, so it's 1 plus 3, 4. Okay, wait, real quick before I just do that 1 there. So we have a 1 here, and we have a 3 here, and a 1 here. So I'm going to add all these little constants. So it's going to be 1 plus 3, because 3 times 1 is 3. So 1 plus 3 is 4. And then we have 3 times 4t squared, which is 12t squared. And then we have 3 times negative 4t, which is minus 12t. Okay, so this is what we got here. So if we were to do f.dr over here, yep, I had to make more space because that was getting pretty claustrophobic. Okay, so it's f.dr, right? So what is f? Well, f is this thing. Oh, f is this thing here, and this is dr. So, okay. So f, and you know how dot products work. It's something in the same direction times something in the same direction. You times those two vectors in the same direction. And in this case, that would be 0 times all that, which is just 0. And it's this times all this, which is going to turn into 2 times 4 times 2 times that. Okay, well, you get what I'm saying. 8 plus 24t squared minus, not a plus, it's a minus, minus 24t. And remember, part of dr was the dt on the outside, so we have to keep the dt on the outside. But remember, this was a dot product, so another word for saying it is a scalar product, so we can get rid of this vector notation and write it as a parenthesis. It's 0 plus 8 plus 24t squared. Why do I keep writing plus? Minus 24t dt. Okay, and let's see again. The reason why I did that, I want to show you that that is our integrand. So now when we actually do our integration, right? And remember, this is our bound, right? Because we're using a vector function, 1 to 0. And I'm going to factor out at 8 here. So it'll be 8 on the outside, because all this has 8. So it'll be 1 plus 3t squared minus 8, not 8, minus 3t dt, which is the same thing as 8 times t plus, okay, 3t squared, its antiderivative is t cubed. And this antiderivative will be 3t squared over 2. And of course, all of this is going to be evaluated from 1 to 0. So if we just, okay, let's guess what this should be. I'm going to guess 4, right? Because I keep saying that everything in the end should all equal 4 because the path is independent. So let's see if this is equal to 4. So this would be 8. This would be 1. This would be 1. This would be minus 3/2. Right. So it would be 1 plus 1 minus 3/2, which is 8. 2 minus 3, 2, which is equal to 8. Okay, that's going to be 4 minus 3 over 2, which is the same thing as 8, 1 over 2. Sorry, that math was really hard for me. Which is 4. Oh, spoiler alert. Again, it's 4. Look at that. We did it 4 different ways. We did 4. What does that say? It says that the theorems are true. Whoever invented this crap is a pretty smart person. Consider subscribing and liking if you found this video interesting or helpful. Leave a comment. Just leave any comment, just so I could, get this video pushed up in the algorithm.